this is Joy Varghese from Uncovering Chemistry. This is video 26, chapter Haloalkane and haloarenes, and today we'll be discussing about exercise question number 10.18, 19, 21 and 22. The remaining whichever questions are there, no, that is suppose in this case 10.20, this will be discussing when the school, that is lockdown is over and we start our school regularly, okay, because in that certain explanations are to be given, okay. So this whichever videos of exercise questions are given, you have to write it in your fair book, okay. So shall we start? Wait, now when we talk about this 18th question, para-dichlorobenzene has higher melting point and solubility than those of ortho and meta isomer. We have already discussed that para products, what we say, no, para product have a good symmetry, right? Means that their packing is good, means the molecules bind in such a way that there is a less number of gap or space when we say. So the melting point of para isomer of dichlorobenzene is higher than that of ortho. The reason is para isomer has symmetrical structure and therefore its molecules can easily pack closely in a crystal lattice, means less gap will be there and close packing is means close packing is there, right? So no gap, no void, nothing. Hence it has a strong intermolecular forces of attraction, and this is the reason. What is the word? Strong intermolecular forces of attraction. That's why the ortho and meta isomer. Therefore, greater energy is required. So intermolecular force, if it is strong, more energy is required to break this intermolecular forces to melt, or the two things are there. See, melt means melting point. Why it is higher, and to dissolve also more energy is required to break this, right? So solubility will increase because dissolving will be tough, what we say, while melting point increases because intermolecular forces is high. So that is the para isomer, then the corresponding ortho and meta. So in other words, melting point of para isomer is higher, solubility is lower because to dissolve more energy is required. And why melting point is higher? Because of the close packing in the crystal lattice and has stronger intermolecular forces. So this is the reason why para isomers has higher melting point and solubility than those of ortho and meta isomer. Okay, now the next question. Next question is 18 number question. You can see again this is conversion. If you see here, there are total 20 conversions in this. So one by one we'll be discussing this. Now this time it will be easier. I already said that for conversion you have to remember the preparations of haloalkane, haloarenes, and also the chemical properties. From your textbook you go through it, so it will be easier. See, now in this case propene, that is the first question. It is you have to convert propene into propane 1 also. Simple. This is anti-Markovnikov rule, right? So where this Br will get substituted to the carbon containing more number of hydrogen, and aqueous KOH. Aqueous KOH means it's a substitution reaction. Which reaction? Substitution reaction. Now Br will get substituted by the OH group. If alcoholic KOH there, then elimination reaction, right? So now the next one, from ethanol you have to prepare what? But2-YNE. So this is little bit different than what we have studied till now, but already we have studied this in the previous questions. Ethanol in presence of phosphorus, this is from preparation of alcohol, you have seen 294 page. So here OH is substituted by I. Again now see here alcoholic KOH. Alcoholic KOH means which reaction? The elimination reaction. So in elimination, iodine will be removed from this carbon and hydrogen from the next. So you will see there is a formation of double bond. Again addition reaction, at these two places Br is substituted, then NH2 and liquid ammonia in presence. You will see here again one hydrogen here, from here Br is removed, one hydrogen of here and another Br. So formation of a triple bond, ethyne is formed. This ethyne again treated with sodamide, what we call it as. So what you will get here? Liquid, in presence of liquid ammonia you will get Na will be substituted in place of hydrogens here, right? And again this Ca3I in excess, methyl iodide, what we say, in excess. That's why here you can see two molecules are given. So it will give you what? But2-YNE, means here there will be triple bond, and instead of this Na, two Ca3 groups will be substituted here. So this is little bit different, so remember this. Now the third one, again you can see here alcoholic KOH, again means what? Elimination reaction. What you will see, Br is removed from this carbon and H from this. So between these two carbon there is a formation of a double bond. Again anti-Markovnikov rule, Br will substituted to carbon, double bond carbon containing more number of hydrogen. It is anti-Markovnikov, Markovnikov. So Br will get substituted at this carbon and hydrogen will be at this. So you can see here Ca3 and Br at the second carbon. Over. Now the fourth one, what we say, same you can see here, toluene, chlorination you do, minus HCl. HCl means here, from here you can see H is being removed and Cl is substituted. Aqueous KOH, it means substitution. So Cl will be substituted by OH group. Benzyl alcohol, this is benzyl chloride. Benzene, the next one, halogenation in presence of FeBr3, bromobenzene is formed. Nitration you do, nitro group will be substituted at para product. This is a major product is also written. You can see NO2 will be substituted to ortho also. But why this is major? Because of less steric hindrance, what will happen? Perfect symmetry, less steric hindrance, far away from each other. So more stable compound. That's why it's a major product. Then the next one you can see here, benzyl alcohol, what we say. Benzyl alcohol when treated with thionyl chloride, you can see this preparation of alcohol what we discussed in haloalkane. You will see OH, Cl is substituted instead of this OH and alcoholic KCN. So again substitution reaction, Cn will be substituted at this position, right? So then H plus, this is acid catalyzed hydrolysis. What will happen? This N will be substituted because we know carbon combined with nitrogen with 3 bonds, what we say, right? So here what it will be, C double bond O dash OH. So this is the COH group, means total if you see carbon, 3 bonds are only there. So how it is substituted, that part will be clear. This is little bit different, remember this and keep. Okay, it will come in the previous chapters, next chapter. See. Then ethanol, again what we said, phosphorus in iodine. So what will get substituted? Iodine will be here, alcoholic KCN. So here instead of I, what will be substituted? Cn. So propane nitrile means ethanol to propane nitrile. Then aniline, NaNO2, send me here what we discussed if you remember, sodium nitrate and HCl. What you will get in presence of this is 0 to 5 degrees Celsius temperature, ice cold water. You will get benzene diazonium chloride. It is a salt and it is freshly prepared salt, because it is not stable for a long time above this temperature also. This temperature has to be maintained. So what will happen in this case? N2 will be removed here, N2 that is here plus N2 gas, right, like this it will come, and chlorobenzene is formed, which reaction? Send me here, we have already studied. See. Now in this case, 2-chlorobutane, Brooks reaction, right? So what will happen in this case? So here you have to take 2 molecules of this and 2. So if you remember Rx plus 2Na plus Rx, but I'll write like this. So what is removed? 2NaX is removed. So here plus 2NaX will come. That is NaCl is there. So 2NaCl and this RR will get substituted. Now this one R and this another R, right? So this will get substituted and like this. This is R and this is another R. So like this is Brooks reaction, simple. Then what is given here? 2-methyl propene, and HCl, Markovnikov addition, you will come to know, chlorine will get substituted with position where it is contain less number of hydrogen. So Cl will go at this position and H will go at this carbon, what we say. So this is the product what is from major product, because it follows Markovnikov rule. Then ethyl chloride, alcoholic KCN, you can see Cl is substituted by Cn, substitution reaction, acid catalyzed hydrolysis. This Cn I already explained here, carbon is attached to nitrogen with a triple bond, right? So this carbon will attach to an oxygen here and one with OH. So it is triple bond only. So this is C double OH, means this one is the group what is substituted instead of nitrogen. Understood now, right? So now next one, 12th one, what we say here, you can see. Okay, what is written in this 12th? But1 HBr and peroxide. Peroxide means what? Anti-Markovnikov. Markovnikov. Right? So anti-Markovnikov means where this negative part, this is negative part, positive will get substituted to such carbon which contain more number of hydrogen. H will go at this position. So here this is the product what we got. Sodium iodide and acetone. So what will happen in this case? Na, this halogen exchange what we have studied here. So NaBr will be removed in this form. Halogen exchange method we have discussed already, right? So here instead of Br, iodine is substituted. Then the next one what we say, this one alcoholic KOH, 2-chloropropane. Alcoholic means again elimination reaction. What will happen from here? What is removed? H is removed, and from this carbon chlorine is removed. So between these two carbon a double bond is formed. HBr peroxide, that is anti-Markovnikov. This is the product aqueous KOH. Aqueous KOH means what? What is the meaning of aqueous means? KOH means substitution. Who? Substitution. Who will get substituted? This OH group will be substituted as Br, and here you will get KBr like this. Over. So this is the part. Then isopropyl alcohol plus 4I2 and this 6NaOH, heat it, you will get what? Iodoform, right? CHI3 is nothing, but we call it as iodoform reaction. This you remember and keep. It will be easy for you to understand. Then the next one, chlorobenzene. This is simple word, what we say, nitration. You will get nitrochloro, that is, you can see here. Now in this is a para position. This is a major product. In this again aqueous NaOH, when we say you use, what will happen? This Cl will be substituted by which group? The OH group, right? So this one is little bit different. You have to remember this. Then the next one, 2-bromopropane alcoholic. Alcoholic means again KOH. So here Br and here H. So between these two carbon you can see double bond is formed. HBr peroxide anti-Markovnikov. So Br will go where more number of hydrogen and H will go where less number. So this is the product what we get. Then chloroethane Na-Wurtz reaction. So there two molecules you have to take, what we say. So NaX will be removed, and you can see this 2 carbon and this one R and this another R. What is there? Go through that Wurtz reaction. Benzene bromination, you can see in presence of FeBr3 as a catalyst. Bromobenzene you get. Na dry ether, that is Fittig reaction. This ArX plus we know 2Na plus we can say XAr, right? So what is removed? 2NaX is removed, and you will see AR is substituted, right? Biphenyl group what we get. Then the 19th one, what we say here, this tertiary butyl bromide alcoholic KOH, means again elimination reaction. From here what is removed? Br, and from this H. So between these two carbon you can see what is formed? Double bond is formed, but it is written little bit like this, but it is understood. HBr peroxide means anti-Markovnikov, so negative part will go to carbon, double bond carbon containing more number of hydrogen, and H will go at this carbon. So this is the product what we get. This is aniline plus, what is this? Chloroform plus 3KOH. This is little bit different, you have not studied till now. You have to warm the mixture. You will see that instead of this hydrogen, what is formed? Carbon will get substituted. So this is N gets attached to the carbon, that's why it is isocyanide. We have seen ambident nucleophile if you remember, plus KCl plus H2O. Now we will see the next question. Now this is question 10.21. It is little bit tricky question and most important also, likely to be asked during board exam, right? So what is written here? Primary alkyl halide A, right? CH4H9Br reacts with what? Alcoholic KOH to give compound B. Alcoholic KOH means elimination reaction. Compound B is again treated with HBr to give you what? C means Markovnikov, which is an isomer of A, like this they are telling, right? So when A was reacted with sodium metal, it gives a compound D. Then that was different than the compound when N-butyl bromide. Now here comes the twisted part, what we say, was reacted with sodium. Give the structural formula of A and write the equation for the reaction. The first of all, C4H9, there are these two isomers are given, N-butyl bromide and isobutyl bromide. One another isomer is also possible if you see CCH3, CH3, CH3 and here Br. This isomer is also possible, but we are discussing these two first, right? Because what they have written here, N-butyl bromide, right? Understood? So from this we get a hint here. So if I take this N-butyl bromide and treat it with what? Sodium metal here. The Wurtz reaction, if you remember, what will happen? 2 NaBr is removed, and this one molecule, these are two molecules. So these two molecules will get attached here like this, RR. If you remember, right? Plus 2 NaX, that is NaBr is there, that's why it is removed. Now if this is the isomer, you will see this Wurtz reaction, you see this is one R group and this is another R group, R-R plus 2 NaBr is formed, right? Now, so here with sodium, this is the reaction what we get. Now if compound A is isobutyl bromide, right? Isobutyl means the second isomer what we have seen. Then the compound B obtained on treatment with what? alcoholic KOH will be 2-methyl prop 1-ene. Means what? In this case, if you see, alcoholic KOH means what? Elimination reaction, right? So if this is the product, then with alcoholic KOH you will get what? 2-methyl prop 1-ene. So here, from here, Br is removed, and from here what is removed? H is removed. H minus H, and here minus Br. So between these two carbon you will see a double bond is formed. That is 2-methyl prop 1-ene. That is the product B what you got, right? Now compound B, what is given here? Compound B on treatment with HBr. HBr means Markovnikov. Compound C in accordance with which rule? Markovnikov rule. So you can see here CH3C, this is the 2-methyl propene. What we say? Not propane, it will go prop 1-ene. HBr Markovnikov rule. What will happen in this case? Br will go at this carbon and H will go at this carbon. So that is CH3 here. You can see 2 was there and 3, and at this carbon Br group is there. So it is tertiary butyl bromide, that is C. Now why this is correct and why we have taken what we have taken isobutyl bromide is correct? The reason lies here. Why? See, C is an isomer of compound A that we have already studied here. Can you see? Means out of these two, one more isomer is possible of this C4H9Br, right? So this is the isomer what you got, and it is given here in the, what is the given here? What is given here? Which is an isomer of A. So this is the A from which we get an isomer at the end here. This is the isomer what we got. So C is an isomer of compound. C is an isomer of compound A. Thus, A is what? Isobutyl bromide. B is 2-methyl propene. What is A? A is isobutyl bromide. What is B? B is, what is written here? See here, what is B? 2-methyl prop 1-ene. That is, we got from Markovnikov rule, right? Sorry, elimination reaction we got. And C is what? Tertiary butyl bromide that we got here, right? And D, what is D? 2,5 dimethyl hexane. 2,5 dimethyl hexane. Now what is that 2,5 dimethyl hexane? Means this is the compound. So if you read the question carefully, step by step, you will come to know why we concluded here like this. Okay. So now we will see the last question of this. This is the last question of our topic. What we say here, you can see. What happens when N-butyl chloride is treated with alcoholic KOH? Okay. Second is bromobenzene is treated with Mg in presence of dry ether, means Grignard. Alcoholic KOH means elimination, what we have discussed, right? And chlorobenzene is subjected to hydrolysis. Hydro means H plus and H2O. Ethyl chloride treated with aqueous KOH. KOH means aqueous KOH means what? Substitution, right? So like this you can remember this. So we will go through the solution now. You can see here this first one, aqueous KOH elimination reaction. This is the reaction what is completed. This is Grignard reagent, AR, Mg, Br, like this what is formed, and that is written here. Then chlorobenzene plus NaOH, you can see here what you will get, no reaction, right? Now this is, you have to go through your textbook, why we have seen this, chlorobenzene, haloalkanes with the NaOH, why it is so. Then you can see the next one, CH3, CH2Cl, that is ethyl chloride with the aqueous. Aqueous means what? Cl will be substituted by OH group, like this. Then this Fruits reaction that everyone know, RR is the product what you get here, and this last one is methyl chloride plus KCN. So you can see alcoholic KCN means CN will be substituted instead of Cl, and this is the product what we get. Few photographs I will give for the summary of this what we say, this chapter. So you just go through it or make a printout of it. Okay. Thank you very much.